All right, now you can see my screen, and I'm going to go to the Blackboard course and show you a few things quickly. The course calendar has all the information as to the plan, exactly what will be taught in each class and what is your assignment afterwards. So here it tells you what is going to be taught in the first class. And here on the right column, it tells you what is your homework right after that. So today's homework is exercise 1.1 in your book. All the questions have to be answered. Next class will be section 1.2, and these exercises are the homework. So everything is right there. You can always look up here to see what is due right after this class. You can see everything right there. Also, if you look at the what is due when, this is basically a calendar. I click at the calendar, it tells you everything that's due. So during this first week up until 8th, you have the time to write the introduction of yourself on forum 1 in discussion board. Some of you have already written some your introduction. I've been reading them. Some others haven't. You need to do that. It's one of your assignments. And then it says you have this assignment 1 due on the assignment 1. I'm sorry, assignment 1 is due on the 3rd. As you can see, if you click there, it shows you what exactly is due that day. All right, so close that. So that tells you what's due when and all that. If you go to module 1, which is the course material, this is the class 1 material that we are going to do today. I have posted the video of that class from the past, from last semester. You know, you can watch that if you like, but that's optional. But right after the class ends, each class ends, I will be posting that video. But it takes about 5-6 hours for the video to process. Unfortunately, it's not something I can post right away. So I will try to post it the same day, but it will take some time. The system takes time to process it. So I will be posting that video of each class after the class. Now you can also see the tests and quizzes link, and that's where your test will appear. You'll be taking test on Blackboard. Right now there is quiz 1. You have to complete this. Quiz 1 is on the course information. The course information is right here. Course information is your syllabus. All the details of how exactly the things will be handled are there. For example, the achievement evaluation, it tells you there will be 3 tests and there will be a final exam and there'll be assignments, and the assignments are worth 35%, final exam is worth 30%, all the details are right there. And when you, at the end of the semester, I have to convert your number grade to a letter grade, and the formula is right here. 90 and above will be A, and 86 to 89 is A minus, 55 to 58 is D minus, that's the lowest passing grade. 54 or below will be failing. So everything is here, and you're supposed to read this and then take the quiz 1. The quiz 1 is basically checking your understanding of the course information, syllabus. Course information is basically syllabus. I didn't want to call it syllabus. So your understanding of that is what I'm checking here. So you need to take this quiz after reading that course information entirely. Now let me show you how to turn in your assignments. Every day after class, not every day, after every class, there will be an assignment. And that's going to be due in the following class. So you need to click it at this assignment link right there and see this CSCI271 homework 1, it says. which is on section 1.1. It says section 1.1, all the problems. Right there, it tells you what is due today, what is the assignment today. And so you need to click at this link. If you click at the link, it'll take you to, one second. Someone just came in. Ahmed Hassan. So if you click at the assignment link, homework 1 link, you get this. You have to write your name here, and the submission title means what assignment you're submitting. It's assignment 1, homework, or section 1.1. You can put either one, section 1.1 or assignment 1. And then, so fill out all that, and then choose your file by clicking at this. Choose your file from your computer. It has to be already in your computer. The file has to be there. And click at that to select the file, and then click at upload. It'll upload it. So everything will be uploaded to Turnitin assignment section. And I'll be grading right after you submit. So after the due date, I will be grading all of them. Usually the next day, you'll be able to see them. And you're supposed to see them before the following class. You must view your homework because I'll be writing feedbacks. Whenever something is wrong, I'll write exactly what's wrong and things like that. So it takes a lot of time for me to do that, to write all those feedbacks. And the reason for writing them is because you will be learning from that. So you're supposed to read them. And if you still don't understand why it's wrong, then you should ask the question in the following class. At the beginning of each class, I'll allocate about 10-15 minutes for discussion of the homework questions. Also, there will be office hours at 2 o'clock every Monday and Wednesday. You also have a tutor. And so I think I had put that here, right here, contact tutor. If you click at that link, you will see the tutor contact information, only the email address. He doesn't want to give out the phone number. So you have the email address, you can contact him. And also he will be setting up help sessions 4 p.m. every Thursday. The tutor will be setting it up. And so you join that meeting and ask your questions. These are all there to help you out, because this course is difficult. It's not easy, and you need all the help you can get. And that's why we are offering all these helps. The tutor is going to be there at 4 p.m. every Thursday. And also you can contact him by email when you need help and ask for a meeting. If he's available, he will set up a meeting. Otherwise, he can answer questions that you send by email. And I can also answer questions if you send it by email. The preferred email is the one that I have here, faculty information, right here, profcoogan@gmail.com. I prefer that you write to this address because this is dedicated to the students, and I will always get to it very quickly. But if you use the John Jay email, it'll be kind of slow to get to that message because all kinds of garbage mails come into that mailbox. So I have to scan through all those to get to your email. So it'll take a while. So if you write to this, you'll get fast response. And before each class, I'll be setting up the meeting, Zoom meeting, and then I'll be posting it here in the announcement area. And everything I post in the announcement area will come to you as email. So therefore, the Zoom meeting information will also come to you as email, in addition to all the other announcements. Okay, and you can always find your grades by looking at My Grades. My Grades link has your grade information. Every assignment grade and test grade, everything will appear here. So I think that's course messages is useful for all of us to communicate. So if you post a message here, uh, even a question, you know, other students can answer it, or I can answer it. So it's supposed to help us communicate uh, with all of, you know, as a group. That's what that is for. You send an email question to me, then only I will be seeing it. If you post a question here, then everybody will be seeing it. And if I answer it, then everybody will see the answer, or another student can answer it, then all of you will be seeing the answer. So it's a communication as a whole class. That's why it's a better way than email. Last semester, my students didn't use it that much. I hope you will be using it more. Uh, so, um, yeah, that's about all I needed to say. You can always look at the course material right here in the modules. The course is divided into 6 modules, and after after 2 modules are finished, you'll have an exam. After another 2 modules, another exam. That's how it goes. The exam schedules and everything is posted in the course calendar. Course calendar tells you when exactly your exam will be right here. Class 11, 11th class is going to be the first test. So you can look up everything. You can get all the information about what is going to be taught, when is the test, everything is right here. And always feel free to interrupt me and ask your question. Any questions so far?
Nope, not at all.
All right, very good. In that case, I'm going to just close this off and open the material for today. Introduction to computer programming. Uh, so let's begin with the section, chapter 1. This chapter basically gives you the introduction to the uh, structure inside the computer, architecture in the computer, some idea of the architecture, not too deep, not too much of details. Also, you will understand what a computer program is and what computer programming languages are and compilers are and things like that, basic information. Okay, so let's begin with 1.1. Your homework today is going to be all the questions that appear at the end of this section 1.1. By the way, do you all have your copy of the book, the textbook? How many are without the textbook? Just
Some are struggling
say,
to get in because of the storm.
I'm
Yeah,
sorry.
am I supposed to come?
Mine was supposed to come today too, but this because of the
Ah,
snowstorm,
okay.
things
In
aren't.
the storm, it's yeah, that's true.
Mine,
Um, yeah, I expected, you know, there would be some students without the book, and there are also some students on financial aid. They're probably waiting for the book voucher. And so for that reason, I have permission from the publisher to give you the chapter 1 uh, in electronic form. So I have it posted already on the, so let me quickly show you where it is.
Yeah, you have an ebook for like 27 days, something like that.
The ebook, yeah, if you buy an ebook, it will come immediately because
Right.
it's electronic.
But
Uh,
you also have a trial version too if anybody needs it.
a trial version.
Yeah, the 20 the code that you provide us for the ebook.
He's
Uh-huh.
talking about the BVT lab.
Yeah, exactly.
The BBT lab gives you that?
Yeah. If
Okay.
anybody needs it, you can actually take a look at that.
Oh, okay. So, all right, there's a hint. If you can take a look at the trial edition, apparently, that they have posted at the BBT lab. That's BBT is the publisher. Uh, so yeah, you can do that. But anyway, I also have this chapter 1 posted here. So let me show you where it is. If you go to the course supplements, that's where these additional things will be posted. So course supplements has the chapter 1 right there. So it'll download it. You can print if you want, or you can just view it online. And all the others supplementary material are here. And by the way, I should mention, I will remind you again later after you get the book. There are some errors, obviously, it's not professionally published yet because of that reason. I have to clear the errors before I can make it an official publication. So there are some errors. And so I have posted these error corrections right here in this document. So as soon as you get the book, I would recommend making these corrections by hand on your copy of the book so that you won't work with the wrong material. You won't work with the material with errors. Sometimes some questions are wrong and the corrections are here. You don't want to work with the wrong question, wrong problem, and answer them in the homework. So therefore, as soon as you get the book, I recommend going to this error correction section, read them, and make those changes on your copy of the book. All right, so that's all I need to say. So let me get out of that and let's get back to the material. Computers and computer programming, basically, that's what we need to understand today. Computer is a machine which can accept and store and manipulate data accurately and extremely quickly. So it can do it very accurately and it can do it very quickly, very fast. Those are the two features of the computer we take advantage of: accuracy and speed. It's only a machine, but it can accept and manipulate data, and also it can take instructions from us. And that's the beauty of this machine. No other machine can take instructions. So most people who never programmed a computer or never understood the computer have a perception that the computers are smart machines. No, that's not true. There's no smartness at all. So if the computer appears to be working, appears to be smart, that smartness is the programmer's smartness. It's the programmer who made that happen, not the computer itself. So it's the programmer who is behind the scene, making the computer do all those things. The computer is only carrying out the instructions written by that programmer. So programmer is the one who is the smart person here. It's not the computer. So a computer is a machine, so it cannot understand anything. This machine can only carry out instructions given by the programmer. And so that feature of carrying out instruction is very useful, but the programmer has to write them. Otherwise, the computer is not useful. So the program is the key here. So let's understand the definition of a computer. See, even your homework question, even the homework, there may be a question that says, what is a computer? So you have to be able to answer it with a reasonable, correct meaning. One student answered once, a computer is a machine. That's all he said. That's not good enough. Okay, you have to be a little more specific. So here is the definition in my words, but you can use your own words to explain the same thing. A computer is a machine that is capable of accepting, storing, and acting on data and a series of instructions given by the user at a great speed with high degree of accuracy. So the key words are, basically it's capable of storing and acting on data and instructions. Both. It can carry out, it can act on data and carry out instructions. Those are the key things. So you can say them in different words, but that point must be there in your definition, if I ask for the definition. Now, solving a problem using a computer. If you want to use a computer to solve a problem, achieve anything, such as solving a problem, then you have to come up with a method to solve the problem. And that's not all. You have to break up that method of solution into simple steps that someone without brain can follow. See, this is a machine that has no brain, right? So you're writing instruction for a machine. You have to remember that. And so your instructions have to be very nice and clean and step by step so that anybody without brain can follow them. That's how clean they have to be. That's how basic they have to be. So that's why writing these instructions is not an easy job. But that's what you have to do. So to solve a problem using a computer, first of all, you have to know how to solve it. You have to know how to break it up into simplest steps that anybody can follow. And you write that as a program. So it turns out that the writing this instruction for the problem to be solved by the computer is much harder than solving it yourself. Why not solve it yourself? If you solve the problem yourself, it's much easier and much shorter. Then why did we write it? We'll go over that in a minute. So let's understand the computer program. Now, I just said a minute ago, if you want to solve a problem using the computer, then you have to write the step-by-step instructions of how to achieve that task. Those step-by-step instructions you write is basically the program. That's what we call a computer program. So here's the definition of a computer program. Computer program is a set of instructions written for the computer to guide it through the process of achieving a specific task. That's what a computer program is. So if I ask you to write the definition of computer program, these keywords must be there. The key word is instructions. The program is a set of instructions, basically. If that keyword is missing, then you don't have the definition correctly written. Now, the program is also called software when you actually market it in the, when we professionally market the software, market the program, we call it software, but they essentially mean the same thing. Program and software are the same thing. So basically professional programs are called the software when they're marketed. Okay, why write program? I asked that question a few minutes ago. I said writing the program is more difficult than solving the problem yourself. Then why do we care to write the computer program? Can anybody answer that?
Once you give it the information, it can repeat that and continue doing that.
Exactly, very good. Once you write the program, it can do that, it can carry out that same task repeatedly for any number of people, any number of times, over and over. So that's the use of the program. Once you solve the problem, then you're solving only one problem. But if you write the program to solve similar problems, then it is useful for everybody out there to solve a problem similar to that, right? Similar situation can be handled for everybody out there. Like the word processor, you have been using word processor. Someone wrote the word processor, it's a lot of work. It is very difficult. They did it. Now we can all enjoy word processing, much easier to type and write, but writing is so much easier with the word processor. So everybody's enjoying the benefit of it. And that's why we write program. It's useful for everybody everybody out there, everybody in the world, to use it repeatedly, any number of times, as many times as they wish. The computer programs are useful for all the people out there once we write it. Okay, so all right, that's one of the reasons. And so why do we want to use computer anyway? That's the question next. A computer can carry out the information accurately and instructions and information accurately, and it can do it very fast. And also, compared to humans, why is a computer better? Because it doesn't get tired. It will be working for a long period of time, right? Without getting tired, without asking for coffee or food, none of that. So here's a machine that can work for you all the time with no supplies needed, right? So compared to humans, that's a great benefit. Still, it cannot replace the human brain, obviously. So it's an alternate to carry out work that we normally do. Everybody uses it. It's a very useful machine. So let's understand the computer system now. A computer system means the whole computer hardware that you're using. The computer itself is usually a little box, right? You would have it on the desk or floor. But just that computer is not useful. You need other devices to go with it, such as monitor, keyboard, and mouse, and all those. All those together, all of those together is what we call computer system. So there are three main components in a computer system. Input device. Input device means the device we use to provide input. Input would be usually, if it is a word processor, then your input will be words. If it is a mathematical problem solver, then your numbers in the problem would be the input. So whatever the input is, you need a keyboard and mouse, things like that, to provide the input. Input devices are, examples of input devices are keyboard, mouse, scanner, diskette, or CD. All these are input devices. Output device is the one that is useful to get the output, the result. What we call output is the result. The result will be usually displayed on a monitor most of the time. But printer is also considered to be output device because sometimes output comes directly to the printer. The computer itself is called CPU. We call it central processing unit. Well, central processing, we'll go into some more details about that in a minute. So the components of the computer will be input device, computer system will be input device, output device, central processing unit. Okay, so let's look at the central processing unit, which is what we normally call the computer. Inside the central processing unit, there is what we call processor. Processor, and then there's memory, two separate things. The processor will be working with memory, and that's why they are connected. Processor and memory are connected. What we call memory here is not the same as what you call hard disk or anything like that. Those are called external storages. What we call main memory or random access memory, RAM stands for random access memory. What we call random access memory is really a memory inside the computer, which is used by the computer only. We don't have access to it. The humans don't have access to the memory. It's for the use of the computer processor. The processor is divided into two units. ALU stands for arithmetic logic unit, and the other unit is control unit. These two units, these two are part of the processor, and then memory is outside the processor. but they are connected. Now let's understand the memory of the computer. The memory is also called internal memory or primary memory or main memory. It is used to store the instructions, basically the program. Every time we run a program, the program will be copied into the memory first. And when we type the data goes into the memory also. So all the things that the computer needs to process have to go into the memory first, including the instructions that tells the computer how to process, which is what we call a program, has to be also in the computer. So only after that, it'll be ready to work with them. It's like, you know, when you need to do something, a task, using your brain, you first have to know how to do it. So that's what the instructions are, you know, how to do it. And you have to have that in your brain first. So it's the same thing here. The computer has to have those instructions in its memory first so that you can carry them out. That's why any program you execute will be copied into the memory first, and then computer will be going by those instructions one by one. So what is the memory for? Memory is for storing the program that the computer is going to carry out or execute, and all the data that the computer will be processing. Everything has to go into the memory. The memory is therefore important, and it's you have heard people saying, I need to upgrade my computer memory. Upgrading means, you know, adding more memory and making it larger. Why do you need to upgrade? Why do you need larger memory? The larger memory is useful because it's like this. When I'm working, the computer will be using the memory when it's working. You know, you will see after you learn how to program, you'll realize that every instruction you write is going to tell the computer to do something to the memory. So computer is doing things to the memory. So memory is its workspace. So it's like, you know, you have a lot of work to do and you have a very small desk space, then it's very hard to do the work. If you have plenty of room to work with, you will be working faster. So that's why if you upgrade the memory, the computer gets faster, because the more memory means more working space. So it doesn't have to scribe for spaces, you know, it has plenty of space. So now it can freely work. So that's why larger memory means faster computer. So you need to allow plenty of memory for the computer. So how's the data processing that we call, what we call data processing is usually same as computer taking the data and the program and then manipulating them to produce an output. So that's what data processing is. Now let's understand operating system. Now I said earlier, a computer cannot do anything by itself. It only takes instructions from the user, right? The instructions are what we call program. So it can only carry out the instructions in the program. Okay, then when we turn the computer on, if there is no program, one student just came in, Patrick. Okay, so I'm explaining operating system. So computer cannot do anything unless there is a program guiding it, right? So if you turn the computer on, if there is no program in it, then what do you expect on the screen? Nothing, right? Computer cannot do anything by itself. So if you turn the computer on, nothing will happen. And even if you type on the keyboard, nothing will happen because it doesn't understand what you're typing. So there is another program that we need to provide to the computer to function like a computer, to understand when we type on the keyboard, to understand when we move the mouse, to you know, to be able to interact with us, to be able to help us. It needs to know how to help us. So Um, so that's why, you know, when you turn this computer on, you're not seeing a blank screen. You see things going on in the background, and suddenly on the screen you're seeing all these menus and icons and all those to make it available to you and to allow you to communicate with you. It brings up all these things, menu items and icons, all those. Where are they coming from? They are coming from a program. So that there is a program that guides the computer through the process of being a computer or being a helpful machine to the human. So that guiding program is what we call operating system. Without the operating system, the machine is useless. It doesn't know anything. It doesn't know how to help us. So all the basic instructions the computer needs to function like a computer, and all the instructions it needs to be able to communicate with us, to be able to understand the keyboard typing and the movement of the mouse, and all those are put together into one big program called operating system. And that operating system program has to be there for the computer to work. So therefore, when you buy a computer, they sell you the operating system with it because there is no use of it. You buy the phone, for example, you know, iPhone, you know, imagine that having no operating system, then it's useless, right? It's just a piece of junk. So you need that operating system, and that's why they sell you the operating system with the computer. And so where is it normally? Um, it is in the hard disk. They put it on the hard disk of the computer. Hard disk is basically an external storage, just like your CD or disk, you know, if you're familiar with the diskette. It's a storage like that, but built inside the box, the big box that has the processor and memory and all that. They put this storage also inside that, and that's what we call hard disk. But it is actually a external storage. So they store it in the external storage and sell it to you with a computer. And so when you turn the computer on, uh, when you turn the computer on, you see that, you know, it takes a few seconds. Nowadays it's seconds, but in the past, when the computers were slower, it takes several minutes. And what's going on in that time is it's looking for the operating system in the hard disk. And then it finds it and copies the entire operating system into the memory. Remember I said all the instructions have to be in its memory before it can proceed to execute them. So that's why the entire operating system has to be copied into the memory first. That's the process we call booting process. The booting process is basically copying the operating system into the memory. And after it copies them into the memory, it executes them. And that's when all these icons and menu items appear on the screen, and the computer is now ready to communicate with us, only after the operating system is copied into the memory. So there's another reason why the memory has to be big enough. The entire operating system has to be copied into it. It's a huge program. Operating system is not an easy program. There are, how many operating systems are there for computers? There are 2 or 3, right? Windows and Mac OS and, you know, a couple of others. Very few, because it's a huge deal to write operating system. It's not easy. So there is not too many out there because of that reason. It's not easy to write, and it's not easy to compete with these existing operating systems and get something better. That's what operating system is, and it'll be copied into the memory as soon as you turn the computer on. Here's the definition of the operating system. Operating system is a program that controls the overall operation of the computer and user interaction. I should have added that, and the user interactions with the computer. not only the operations of the computer, the user interactions are also controlled by the operating system. All right, let's move on. So where exactly is the operating system? I already explained that. It would be in the hard disk in the modern computers. But in the older computers, if you go back to like 70s and 80s, the computers didn't have hard disks then. So we had to have the operating system on a disk. And that disk would be called system disk or startup disk. And when you turn the computer on, you had to insert that disk so that the computer can get the startup program, which is operating system program, into its memory. And only after that, you can use the computer. So during for the computer to be able to function, it needs the operating system, and it copies operating system into the memory, and then it functions it. And then what happens when you turn the computer off? When you turn the computer off, the memory will be shut down, because the computer memory can hold data only as long as there is power. You will understand why later as we proceed to learn more about computers. But at this point, you need to understand that the memory can hold data only as long as there is power in it. So when you shut it down, everything in the memory will be erased. And that's why when you turn the computer on again, it has to get everything from the hard disk again. It has to copy everything from the hard disk back into the memory. The memory will be erased every time you turn the computer off. Okay. It is the operating system. I don't know what happened to my title here. All right. Anyway, it is the operating system that determines exactly how the computer behaves and the computer communicates with you and things like that. So the two different popular computers, computer operating systems are, what are they? What are the two popular computer operating systems nowadays?
Windows and Mac,
OS
right?
X.
Windows and Mac OS. The Mac operating system of the Macintosh is called Mac OS.
Right.
So Windows and Mac OS are the two popular operating systems. And so why do these two computers, Mac and a Windows-based computer, they look different and they work differently? Some people like Mac better than the Windows, others like Windows better than Mac. And what's the difference? The difference is the operating system, how well the operating system works with the user. Basically that's the difference. So the reason why the two computers are looking and working differently is because of the operating system. It's not the hardware itself. It's not the computer itself. It's the operating system that makes the difference.
Right.
I need to explain to you about the older operating system that we used to work with. Before the Windows came along, the operating system that was commonly used was DOS, D-O-S. DOS stands for Disk Operating System. The operating system it came in on a disk, and I don't know whether that's the reason why they call it Disk Operating System or not, but it is called Disk Operating System. And in this operating system, you basically, you turn the computer on and provide this operating system. All it knows is certain commands from you. It can understand certain commands from you. So you have to know those commands. So you turn the computer on and you provide the DOS operating system. There will be no menus and icons on the screen. It'll be a black window with a blinking cursor, and you have to know what to type next. So you have to know the commands. So that operating system was difficult because to be able to use it, you have to know all those commands. So people who want to use computer have to go through a course which teaches you what those commands are and how to use them. So it was it was a headache to use computer with the DOS operating system. So that's why this Macintosh became a hit. It was the Mac that first came out with this operating system that offers these icons and menus and mouse and all that. So when they first came along with that, it was immediate hit because, you know, that's much easier to use than DOS, right? And DOS was at the time the software produced, operating system software produced by the Microsoft. The Microsoft was the dominating software company at the time, and their best product was DOS. And so after the Macintosh became a hit, Microsoft realized that they have to do the same, otherwise they're not going to be in business. So they basically copied the idea of Macs to produce the Windows. The Windows operating system is a copy of the Mac. And so obviously, you know, the Macintosh manufacturer is not going to let them get away with that. They filed a lawsuit, and the lawsuit took a while for a solution, for a judge to finally come up with a ruling. And the judge ruled in favor of the Windows. He allowed it. And that's why the windows are there. Otherwise, the window would not be out there. It would be only Mac. Now, why did the judge rule in favor of the windows? Because the lawyer argued that if Ford is the Ford company invented the car. They built the very first car. So if the Ford had all the right to manufacture the car, there will be no other manufacturer of the car, and there will be no competition. And so the market will suffer from having no competition. So you have to allow that technology to be copied. And that's the argument lawyer made, and he won. You know, in a way, he's right. You know, there must be competition. So that's why in the market you still have Windows. Anyway, that's just a little bit of history. Now going, yeah, so that basically, here's the last page. The operating system determines the user-computer interaction, which we call the interface. So how well the computer interacts with the user is what we call interface, and that is basically determined by the operating system. So different computers appear to be working differently. That's basically Macintosh and Windows appear to be working differently because they have these different operating systems. Now, right now, the computer I'm using is a Mac. I use both, but it's just my personal view is that, you know, I like the Mac better than the Windows. It's, in my opinion, the Mac is more like a luxury car as opposed to normal car. That's my opinion, but others have different opinion. Anyway, that's basically our exercise section 1.1. Now the I'm going to get started with 1.2, but your homework is only on section 1.1. So let me close this. So the problems at the end of section 1.1 will be your solution, will be your homework, and you need to write up your solutions. Even though I think I made this point somewhere else, but let me mention to you again. If you handwrite it and take a picture of it and upload it, the system will accept that. You know, I mean, that's you know, if you don't have any way of typing, that's what you have to do. You can either, the handwritten paper can be either photocopied or, I mean, you can either take a picture of it or you can scan it on your scanner if you have one and then upload it. But it will be best if you can type it. You don't have to type more than just the answer. For each question, I advise you to just type the number, the question number, and write the answer. Do not write the questions. And no matter how many times I say, some students write the questions in their assignments. If you do that, not only you're wasting time writing the question, but also wasting my time because I'm now reading the questions. So don't write them, just write the answers. That will be the best. And so I recommend typing because the typing works better when I provide the feedback. From my past experience, if I write my feedback on a picture, JPG or PDF file, they're not coming out very good because of the resolution, I guess. Sometimes my writing becomes too big, or sometimes it's too small for you to read, and all kinds of problems are there. So if you type it, then no problems. You type it with any editor. It doesn't have to be a word processor. If you don't have any word processor, there's always Notes. Microsoft Windows comes with the Notes, and also it comes with other editors. So just use any of the editors and type it and save it on the computer and then upload it. It'll be much easier for me to grade and for you to read my feedbacks and everything. So it doesn't take too much time to type, compared to if you handwrite it, you're going to spend time scanning or photocopying and or taking a picture and transferring it to the computer. All that is the process. But compared to that, typing is not much more time consuming. It's about the same time consuming. So please type them and upload them. Let me close this. Any question, feel free to interrupt at any point and ask your question if you have any. Anything so far? All right. Let me close that. Okay, the machine language is our lecture 2. I'm just beginning this, but I won't be able to finish this today, but it is a good idea to begin because it does take a little bit longer than one class. The machine language is the language of the computer. It is the only language the computer understands, and we as programmers need to understand this language a little bit. We don't need to understand a whole lot about it. There's a lot more than what we're going to be learning here about machine language, but we need the basic understanding of this language. And so we're going to go into some of the details of this language. So let's understand the machine language and data representation. The only language the computer can understand is called machine language, or it's also called ASCII code. In this language, all the characters and numbers are represented by a set of zeros and ones. A group of zeros and ones will represent the characters and numbers. To represent the characters, there will be exactly 8 of these zeros and ones will be arranged. These zeros and ones are called bits. So there will be exactly 8 bits in the ASCII code of a character. So for example, the character A, uppercase A, has this code right here, 01000001. So by making different arrangements of zeros and ones, they coded all the alphabets in the English language. So uppercase A, lowercase a have different, all have different codes. These are called the ASCII codes. All these ASCII codes together is called the machine language. So if I ask you the question, what is the language of the computer? Your answer should be machine language. It is the name of the language. You cannot change the name of the language, right? So the common wrong answer I get for this question is computer language. There is no language called computer language. Any other answer is wrong. These questions like that are in your homework, and so you should answer them carefully. So the reason for making up these codes for these characters is because only these bits can be represented inside the memory. The zeros and ones can be represented inside the memory, and we cannot represent the characters as we know, the alphabets and the numbers that we use cannot be represented inside the computer exactly the same way. They can only represent it by only if you represent them by these ASCII codes, then they can be represented inside the computer. Only the zeros and ones can be stored in the memory. That's the basic idea. Only zeros and ones can be stored in the memory. You'll understand that later on in this section. When we get to it. So the key points right now is the language of the computer is called machine language. And in this language, all the alphabets and numbers are coded using zeros and ones. These zeros and ones are called bits. For each character, there's an 8-bit code. For the characters, there are 8-bit codes. For the numbers, the codes are not necessarily 8-bit long. They can be longer. But the characters have 8-bit long codes. So let's understand binary coding. In this machine language, all the numbers are coded using what is called binary coding. So the first thing we need to understand is how the binary coding works. To understand that, let's first understand the decimal coding system that we are familiar with. All of us use decimal coding system for our numbers, such as number 52. When I write 5 and 2 next to each other like this, you read it as 52 because you were told that the 5 represents 50 and 2 represents just 2. So you read it as 52. So the 5 represents number of tens. There are 5 tens and 2 ones in this number. So this writing 5 and 2 next to each other is a code to represent 52, right? This code is called decimal coding. See, they didn't put it that way, so you didn't think about it, but really it's a coding system in which each digit represents different amount of number. So the 5 represents 5 tens. So if I write 2354, I read it as 2354 because that's what we were told. But really, the 4 represents number of 10 to the zeros. 1, 10 to the 0 is a 1, so a number of ones. The 5 represents tens, number of tens. The 5 here represents number of tens. So it represents 10 to the 1s. The 3 here represents 10 to the 2s, 100s. 2 represents 1000s, which are 10 to the 3s. So each digit here represents a power of 3. How many certain power of 3 are there? 4 10 to the zeros are there, 5 10 to the 1s are there, 3 10 to the 2s are there, 2 10 to the 3s are there. That's what these mean. So they represent powers of tens. So since they represent powers of tens, we call this decimal system. The word deci stands for 10. So the 10 is the base. See, we say 10 is the base of the system. Why 10? Why do we use 10 as base? Because the 10 is so easy for us. If I want 10 to the 5, I just have to write 5 zeros next to 1. So it's so easy to calculate different powers of 10 and multiples of 10. They're easy for us to work with. That's why we chose 10. So we use our human number system. 10 is used as 10 is the base. So when we use 10 as the base, all the digits in front of it would be less than 10. You will never write a 10 instead of 5 here. Why? The 10 times 10 to the 1 will become 10 to the 2. That'll be counted here, right? So there's no reason ever to write a 10 here. So it'll be always less than 10. That's why these digits will be 0, 1, 2, all the way to 9. There will be 10 digits which are less than 10. Each one is less than 10. Those are the digits that will go in front of these powers. Okay, so when we use 10 as the base, all the digits that would come into the number, all the digits that are used to form the number will be less than 10. And they are these digits. We made up these symbols for them, but these are the digits. They're all less than 10. All right, so that's the point about the coding, decimal coding system. Now, I already explained why 10. The 10 is easy for us humans to work with, and different powers of 10s can be easily calculated without using calculator. So we use 10. But when you use, okay, let me put the question this way. Why can't we use 5 as a base? Can we use 5 as a base? Yes, we can. Then it will be a different numbering system. We never had any reason to use 5. So there is no numbering system with the 5. But instead of 10, well, if you use 10 as the numbering system, for humans, it's okay, it works. But for the machines, it doesn't work out because these 9 different symbols cannot be represented inside the computer. So therefore, they decided to adopt a different numbering system for the computer, because 9 different symbols or 10 different symbols cannot be represented inside the computer. But there are 2 symbols that can be represented inside the computer, 0 and 1. So we need to be able to code all the numbers using 0 and 1. Only then we'll be able to represent those numbers inside the memory of the computer. So that's why 2 became a popular base. Instead of 10, if I use 2 as the base, then the numbers, the digits in front of these powers of 2's will be less than 2. What are the numbers less than 2? 0 and 1. So all your digits will be 0 and 1 if you use 2 as the base. So that's why 2 became the base for computer language, the language of the machine, which is called machine language. So in this binary coding system, your digits that represent the number will be the digits, which are the digits that go in front of powers of 2's, 2 to the 0, 2 to the 1, 2 to the 2. So going back to the decimal expression in the decimal coding system, we call the number as 2000. We code this number 2354 by writing 2354 next to each other, because 2 was the power of 10. 2 is the coefficient of 10 to the 3. 3 is the coefficient of 10 to the 2 in this expression, which represents the total value of the number. This is the total value of the number. So therefore, To get the binary coding of a number, we have to express that number as sum of powers of 2. 2 to the 0, 2 to the 1, 2 to the 2. And so on. So if you represent the number as sum of powers of 2, then we'll have the binary coding. So here is the binary coding of 13. 13 is equal to, okay, I should show you that. That's going to be my last example. So let me show you on the board here. I have a writing board I can write on. The 13, to find the binary code of 13, what I have to do is I have to write, start by writing 2 to the power 0 and 2 to the power 1, 2 to the power 2, and then I have to stop somewhere. I had to ask the question, where do we stop? All these things that I'm going to write here should add up to 13. So 2 to the 2, everything I write has to be less than 13. 2 to the 2 is 4, which is less than 13. 2 to the 3 can be included, it's only 8. 2 to the 4 can be included, can we include that? That's 16. 2 to the 4 is 16. So we cannot include that. So 2 to the 3 is the highest power. So once you determine the highest power, you would put a 1 in front of it. You start by putting 1 in front of it. So that equal to 8. Now you ask the question, can I add 2 to the 2? 2 to the 2 is 4. If I add 4 to 8, that'll be 12. So that's within 13. So therefore, yes, we can add that. So that's when you put 1 to make it include. So that's included. Now we have 4 here. 8 plus 4 is 12. So I cannot include 2 to the 1 because then it will be 14, right? The sum will be 14. So therefore I put 0 in front of that. And so now I have 12 total, 8 plus 4, 12. So there's one more 1 needed. So add 1 times 10 to the 0 to 2 to the 0. That'll be equal to 1. Now they add up to 13. So therefore I have expressed 13 as a sum of powers of 2. So these digits that are in front of the powers will make up the code, binary code. So therefore I have 1, 1, 0, 1. This is the binary code of this is the binary code of 13. So binary code of 13 is 1101. Okay. All right. So so here is something I want you to try. Determine the binary code of 78 and 65 by using this method. So whether you do it or not, we will be doing it in class, in the next class. So we'll stop here, and I haven't completed this section, so there's no homework on this. Your homework will be only section 1.1, all the questions. So section 1.1 questions are basically, it's all just questions and you need to write your answers. Do not copy the question. For each number, write the answer. For example, one question can be, what is operating system? Then you say operating system is a software that controls overall operation of the computer and the interaction with the user. So, you know, just like that. So write those answers for all those questions and submit it on the Turnitin. I showed you where to submit that. It's a Turnitin section of the Blackboard. The assignment section, assignments, and then click here. This is where you submit your first assignment. All right. Any question?
Nope, not at all.
All right. So
Thank you.
you're welcome, and have a nice day, everybody. And I will see you Wednesday. And you have to submit this before the 5 minutes before the beginning of Wednesday class. All right.
Understood. Thank you.
Thank you. Take care.
Thank you. You too.
Thank you.
Professor?
Bye, Professor.
Bye-bye. Have a nice
Professor?
day.
Hello?
Yep.
Hello?
Question?
This is David. I came in a little bit late today for class.
Yes, I did take attendance. I have your name marked in. See, I have to admit everybody, so I'm able to write down who came late and everything. So I have the information.
Oh, okay.
All right.
All right. Thank you.
Yep, you're welcome. Have a nice day, everybody.
You too, sir. Take
Professor,
care.
Yeah.
this is Ivan Kulikov. I'm connecting from two devices, from my phone and laptop also. Don't be surprised because there's two Ivan here.
Oh, okay. Yeah, I see two Ivans.
Yeah, because one from laptop, one from phone, because my mic on the phone much better than on a laptop.